Okay, folks, can you hear me? Is this microphone working? Okay. Well, everyone can hear me, right. Hi, I'm Anthony. I'm going to talk to you today about test driving user interfaces. So, it's widely considered to be one of the hardest parts of your application to test drive. If you're writing TDD, then people often say, don't bother test drive the interface, make it super thin. You know, use a humble dialogue, make it super thin view or whatever. I think that actually, in some sense, that means that you've got code in your application that is not being tested, and I don't like that. And also, it means that then you've got to actively decide about the boundaries precisely. Okay, this bit of business logic that's really important. It's about quite the order that things end up in the UI, quite how they manage. Do I need to carefully separate that off and stick it in the back end just so that I can have a super thin UI that doesn't have any business logic in? That seems like a bad sort of distinction that you're having to make. So I say, let's test drive our user interfaces as well as the rest of our application. Oh, it was on Dave's slide this morning. If it hurts, do it more often. Yes, it can be tricky to test drive user interfaces, but when it comes to it, as you do it more often, it becomes easier, you get used to it, you develop the thought processes that are appropriate to test driving user interfaces, you develop the necessary support libraries and work out which are the best tools to use and the way you structure your code. It just gets easier with practice. Okay, so I'm going to talk to you about three things fundamentally today. Firstly, what does it mean when I say test driving a user interface? Then, why do people think that it's hard? And what makes it hard? And then finally, I'm going to say, well, how can we actually do this? It's a hard thing. Can we do it? So what does it mean to test drive our user interface? Okay, well, fundamentally, it just means take your standard TDD cycle and apply it to your user interface. So you write a test, a simple test, for what you want to accomplish. You make the simplest possible code that will make your test pass. And that includes the code that makes up the UI. So that's, if you're working in a web app, that means the bit of the little fragment of HTML that's necessary to produce the thing on the page, or the JavaScript code that's going to drive that creation of the DOM element. And then any necessary code logic behind that, if it's that provides the necessary behavior to make your test pass. Then refactor. Standard part of our test-driven development cycle, refactor, simplify your code, reduce duplication, and then go again. Loop back round to the beginning, write your next test. If you're doing it small, incremental tests, then it gives you a nice opportunity to structure code in a way that makes it clear what it is you're trying to do and makes the testing sort of a core part of it, and you get beyond lots of the difficulties by writing it in small baby steps. Okay, so that's what I mean, but why is it hard? Okay, now the first reason it's hard is because people just generally don't know how to do it. It's not something that's widely discussed. There aren't a lot of books on the topic. There's not a lot of articles on the topic. So people just don't know how to write programmatic UI tests. They might know how to write whole application UI tests. There are tools to drive your application through the UI, which people use for acceptance testing, for final integration testing, things like that. This is not what I'm talking about. I'm talking about fine-grained testing. And people just don't, as a class, software developers, we don't know how to do it. And often the reason for that is that the frameworks that we use don't make it easy. They're not designed with the idea that you're going to be writing these programmatic tests. Sometimes, if we're fortunate, then incidentally they do. They do provide the facilities which we need, but often they don't. It's not something that's a core part of the DNA of the frameworks that we use, whether they're web app frameworks or desktop frameworks, whatever. It's not something that's a core thing, but top of the list of what are we trying to achieve with our framework. Testability, not there, the UI frameworks. And because we're not thinking about testing our code, testing our UIs, and our frameworks don't support it, and we haven't, it's not something that we're thinking about, then we structure our code in a way that doesn't support it. If you've been practicing using TDD, who here uses TDD? Is there? Okay. If you think back to the time before you started using TDD, and think of how you structured your code, and now think how you structure your code now, there's clearly a difference in most people, the way they've structured their code. If you're using TDD, you end up with far less coupling inherent in your code because you're doing small, fine-grained tests. With our UIs, we haven't learned that lesson in most cases. And so we still end up with lots of coupling from the UI to all sorts of bits of our application. And our code then doesn't support the testing that we'd like to. You end up driving through the UI, you end up having to pull in too much of your application behind it. And then, of course, people write their UI tests after their code because they didn't know how to do it beforehand. And so they use the integration testing applications, Selenium, Test Complete, these sorts of things. They drive your application through the UI. You provide either a complete web app or a desktop executable, and then automate it, and then check that the whole results are there. These are valuable tools, and it's a really useful thing, but this is not test driving your UI. This is after-the-fact testing. And then, of course, it's an unfamiliar way of working, which boils down to the same. People don't know how to do it. They haven't got the tools. They're not familiar. It hurts, so let's do it more often. Okay, so I'm just going to have a quick aside here about seams. Michael Feathers, in his book Working Effectively with Legacy Code, defines a seam as a place where you can alter behavior in your program without editing in that place. So this is great for us when we're doing tests, because we allow us to separate the code that we're testing from all the rest of the application. You want to test a little bit of UI. We don't care whether the database works. Not for this. I mean, we hope it does before we ship our application. But right now, we don't care. We're focusing on the UI. So we want to separate the UI from the database. We need a seam, somewhere where we can stick in a special sort of testing database, even if that's a function that always returns the same value, because that's what we want it to do. Typically in seams, we have typical seams that we might encounter. We've got callbacks, virtual functions, interfaces. If you're writing a desktop application, then you can have link time seams. You can actually substitute a different version of the same function. But often that is harder to achieve, and that's more sort of a legacy code sort of style where your functions are fixed in advance, and then so you've got to substitute a new version. But callbacks, things we use all the time. Virtual functions, again, things we use all the time. And interfaces. If your code uses an interface, you can have a test-specific implementation that implements that, rather than just specifically, rather than having the production implementation. So you can put an interface over your network layer. You don't have to send packets over the network. You can just assume they've come back. Or you can simulate an error coming back that way. Okay, so back to our user interface tests. From a TDD perspective, and I'm sure you've all found this, works best when the tests are written in the same language as the code under test. You can write driver apps, you can use Python to test your C++ if that's what you really like to do. But actually, if you're trying to use different languages, then you end up having to build infrastructure code that allows you to call the code that's being tested from the language that you're trying to test it with. And that can be a bit of a pain. And it means you've got to think of two different things at once. So really, it works best when the language is in the same thing. And this also provides the easiest way to get a seam in place. Because if you're using callbacks, you can just substitute in a different callback from the same function, from the same language. New function, pass it in. You can derive a new class and override the virtual functions. You can provide new implementation of interface. With different languages, it's harder to achieve. It's also easier if the framework supports you. As I said already, then the range of support from frameworks varies quite considerably. Now, JavaScript frameworks often allow you to trigger events in code. In jQuery, you can just call functions which trigger the click on a button and all the events attached to that. But not all of them do. They're not always necessarily straightforward, but that facility is often there. On desktop frameworks, you often don't get that. If you're looking at Qt or MFC, then you just don't have the facilities to say directly, there's this object, I want you to fire whatever code is triggered from my interaction with that object without knowing explicitly in advance what that code is. Because you can call your function in your class, but that's not testing that it's hooked up to the UI correctly. Okay, so now I'm going to provide you two examples of the same sort of app. It's going to be a simple search app because this is a short talk. We've only got a short time for examples. I'm going to show you one example with JavaScript and jQuery, and then a similar example with C++ and MFC on Windows. Okay, so really basic web app. It's one page with a search box. And there's a button, you type in your search term, you click the button, and rather than refreshing the page, it goes away and does a background search. You might have this as a widget in the corner of something on an app where you allow the user to interact with the rest of the page. And it's a really basic example, but that's just give us something to hang things off. So we have a little widget, looks like this. You can search box, search button, somewhere for the results to go. Okay. Bear in mind, at this point, we're not testing the CSS. We don't care what this looks like, just that it's got the right controls. You can write tests for your CSS, and in fact, it's important to do. And so an aspect of that is more thinking, what is it you're testing when you do that? I'm just going to talk about that for a second and say, well, if you're testing the visuals, then we're not thinking pixel perfect rendering because the rendering of a button, say, varies between your different browsers. But what you might want to check is that your button is aligned with your edit control, or that all the buttons down one side are all lined up, or that the spacings are equal, or that if you've got various widgets on a page that they haven't wrapped around onto the next line when they shouldn't have done, things like that, or that if you resize the browser, then things flow correctly. You can write tests that do that, but for this little example, we're not fussed with that. We don't care what it looks like. We test, does it have the behavior that we want? Secondly, as I said earlier, doing this test and doing it TDD includes the HTML as well as the JavaScript. So we're testing the whole aspect of the UI. We're not just testing, well, somebody's written the HTML over there, and they're giving us this HTML, and now we're going to test some JavaScript. And it's a valid way of working, but that's not what I'm thinking about. We're creating the HTML as we go along. It's part of our application, so we're going to test that it's correct. And thirdly, we're going to trap the AJAX call that sends the request to the backend. We're not testing the backend, we're testing the UI. So we're going to trap that AJAX call and simulate the results in our test. Okay, so let's have a first test. Can everybody read that at the back? I see nodding heads, so we'll carry on. Okay, so it's jQuery. We're going to find the body element. We're going to clear it out, and we're going to load in HTML from load a fragment from our search of HTML, search form.html, load it from a file, and stick it in. Now, quite how you do that is up to you. You can have that. I'm going to leave that load HTML from file as an opaque function. How you organise that within your test framework is up to you. But I like to have a function that does this, and that search form.html, that very same file then gets loaded into your live HTML code. Whether that's whether it's compiled in and assembled as part of your build and release deployment, or whether it's actually loaded from a little fragment at runtime as part of your application, or any other way that you like to do it. That's up to you, but I wouldn't say that. If you edit that search form.html file, any change you make there has to make it to your production code. Otherwise, you are not testing your production code. You don't want 2 copies of your HTML. Okay, so then we've got the core of our test. We find our edit box. We check that there is in our body we have a form with an input which has got a class of a search term. And we check that we have exactly one of those. And we pop up an alert. So when we run this test in our browser, we will get a message box that says, you've got the wrong number of edit boxes. Of course, there are frameworks for writing tests in JavaScript. I like QUnit, but you don't need them to write a test. You can just stick an alert in, and it pops up. It's as clear as any other form of error reporting, but it's more interactive, and you might want to run all your tests and then get a nice green light or a red light in the page at the end. Whereas if this one, then you'll get an alert on the first failed test if you use this sort of thing. Okay, so we make it pass. We create our little search fragment. It's a form with an input box. Now, that's all there is to it. We have now, if we run that, then then our test will pass. And here's the driver page. That actually does it. We load in jQuery. We load our application JavaScript, which at the moment we haven't got any. It's going to be an empty file. We've got our test function that we've just shown on the previous page, and then the actual driver code at the bottom there. When the document is ready, then we're going to run our test function. And at the end, we'll print success if our test succeeded. And if it failed, well, we had the alert already. It's as simple as you can get. You don't need frameworks. If you've got a framework for testing, use it. It's great. But you don't need it. Okay. Ajax test, on the other hand, a bit more complicated. At the top line there, we've got load search form. It's the function I've extracted. If you've got the same bit of code in 2 functions, extract a function to remove duplication. This removes the duplication because we would have had to clear the body, load the search fragment from the HTML and stick it in the body. So rather than do that, extract a function to do it. Then we've got a dummy Ajax function. We're going to use this as a callback. We're going to pass in the URL and the data and the handler that is going to get called when the supposed Ajax call returns. But for now, we're not going to do anything with that. We're just going to stick it in our array. We're going to push it on the end of our posted Ajax, which is a local array up there in the top right. The core function that we're testing actually here is setup search form, which is on the next line, which is the JavaScript that's going to run to attach any handlers to our form. We've got the HTML. We had that from the previous test. Now we're setting up the form. So in your production code, when the document is loaded, as part of your widget initialization, you're going to call this setup search form function. And you're going to pass in the jQuery form handle to your form that's going to be your search form, and the Ajax callback. Okay, now the next line is an unfortunate consequence of the way that forms work, and that's just we're going to make sure that if we've not hooked things up correctly, then our form doesn't trigger a reload of the page by going somewhere. Because if it triggers a reload of the page, we're running our JavaScript in the browser, reloading the page, kills all our tests. We've just loaded a new page afresh rather than actively running. And if you've got things set up badly, you can end up just with an endless browser loop as it loops around to keep reloading the test page. And then you end up with a squillion alert boxes, which is just never good. So we clear out the actions to make sure that our form doesn't reload the page automatically. Then the next bit is our core test. We're going to find the search box which we already know is there from the previous test. We don't have to test it again right here. We're going to find the search term box. We're going to stick in some content. Then we're going to find the search button, which we ought to have had a test to check there was a search button. I'm skipping ahead now. In order to sort of show the more complicated test, I've skipped that one. And then we're going to click it. And this is where jQuery support for event triggering is nice. We don't care what the function is that's attached to that button. We don't even know if there is one. What we do know is we're going to click it, and we're going to call any event handlers that are attached. And then we're going to check that after that, we did indeed get something in our Ajax array, because our Ajax callback was invoked. We're going to check that it was indeed, the URL was right, it was a search, and it's got the data. We got the red widgets that we put as our search term. And if we don't get that, we're going to pop up an alert. Okay, so yeah. Like I said, simulating the click is easy if you've got framework support. We don't know how the click is attached, but we do know it, but we hope that it's there, because that's what we're testing. Is it there? Did our setup search form actually attach an event to this button, so when it's clicked? So then we make it pass. Here we are, we've got a setup search form in our app.js. We find the search button, and we attach a click function. And our click function calls our Ajax callback that we provided as parameter to the function, which in our test is going to be our dummy Ajax that's not actually going to do anything. We pass in the URL. We pass in the value that we're retrieving from the search box. And what we haven't got, it's a dummy handler. This is a test. We haven't tested that it does anything when it gets when the search results come back. So we don't need a handler. We just have an empty function. Do the simplest thing that will make your test pass. We don't need to worry about what the handler does yet. We just need the simplest thing, which is an empty function. And then, of course, we return false from our click function to make sure that it doesn't activate the default form submission process. So that's all that's needed for our first Ajax test. The test will verify that we've submitted the code. That we do actually post an Ajax request to the backend. We don't need a backend yet. We're not fussed about whether the backend works. Is the request there? And this tests it. And that's the simplest thing that will make it pass. Of course, then you need to actually check that it does something with the results. So now we have a new test. Baby steps. We've got simple tests to check that the UI elements are there. Another test to check that when you click it, it actually sends a request. Third test, that when the results come back, then we actually do something with them. And then after that, you would then add error handling, other UI updates. You might want to have a test to say, no, disable the button whilst the search is happening so you can't spawn off a million buttons, just somebody hammering. It's not coming back. Hammer, hammer, hammer. I want my searches. And so they spawned off 1,000 searches before the first one comes back. So you'll have tests for that. But for now, we're testing what does it do with the results. So we've got the same sort of intro as we had on the previous test. Loading the search form, got our dummy Ajax function, we set up the search form, we put the red widgets in, we call click. Now we're going to simulate the results. Got some result data. 3 types of widgets come back from our search. Spinning widgets, fast widgets, big widgets. They're all red, of course, because we're searching for red widgets. And then in our test, we invoke the handler that was provided as part of our posted in the call to that dummy Ajax. So you call the click and it sticks a handler in. This is asynchronous, so the click result is going to click function will return and think, I've spawned off my Ajax, now I'm going to wait for it. So now in the test, we can call the handler. So we're simulating the results coming back from the backend. And we're going to pass in the result data. And then we're going to check. We're going to find the results and check that it is there. There is a div for the results. And that it has the right number of children. In this case, I've decided that results are coming back as an unordered list. Again, we don't care what the styling's like. You can style your unordered lists in many ways. But for now, we just got an unordered list with one list element for each thing in our list. And you would want to add to say, well, is the first one the spinning widgets, the second one the fast widgets, and the third one the big widgets? Because that's what, if that's important to you. Or you could test that they were sorted in alphabetical order if that was what was important to your app, that whatever result order the search results came back, they were displayed in alphabetical order. You could test that. But for now, we're just checking that we've got 3 entries. So how do we make it pass? Well, we just extend our setup search form function. We extend the thing. This time now, we need a handler. There is, when we call our Ajax function, we pass in this handle results, which we've defined at the top. A function that takes the data that comes back, builds a result list, and sticks it in the UI, in the div. In the dot up in the top right there, then we create a list element for each, but it's fairly obvious code and it didn't fit on the slide. So it's a simple extension of the code that we had that made the test pass last time, and so we're only focusing on just what needed to be changed. But it gets us where we want to be, and it's the simplest thing that works. If it's not as tidy as you'd like, you can refactor it in a minute. But for now, the simplest thing that works, simple iterate through the results list. Again, if you can think of a case where, well, what if it does this? Well, write a test. Straightforward. We're doing TDD. We're all used to that sort of thing. Okay, now, of course, in the test, we had a dummy Ajax handler that we were passing to our search forms. If you're writing live code, you need a real callback to call. But you can just wrap jQuery's Ajax thing. A simple thing. So we've got our jQuery Ajax function. It calls $.post, passing in the URL and the data and the handler that was supplied. And I've also extended this one to provide a failure handler in the case that your Ajax call doesn't work. The server's offline. Somebody pulled the network cable out of the machine, or whatever. And so, if the call fails, then we call our failure handler. So you can stick this function in your live code, and it's a one-line function. It is, well, not quite one line. It's very, very simple. You can see whether it works at a glance, and it needs much less testing than all the infrastructure. You can check that this works almost by eyeball. So you can just stick that in your live code as the callback that you're using. And, well, if it doesn't work, then your whole system will fall over as soon as you turn it on. But you can test that as part of your integration tests, rather than having to be as part of your TDD tests. And you could, of course, write an integration test just for this function if you really wanted to. But then it's this. You can use. So then you've got the dummy test function that we used for our testing purposes, and then a replacement callback that we use for our live purposes, but we don't then need to alter our setup search form code. Okay, so now we're going to move on to C++ example. Again, thinking a simple search, just to give the contrast between the JavaScript and the C++. We have a dialog box, and we've got a search term, put in at the top, a button to click, and somewhere for the results to go. So here's our test. We're going to test that the search request is sent on the click. Now we're going to go straight for testing the call to the backend rather than testing that the UI is there, just because this is the more interesting bit. And it's only a short talk, and there's not as much time as I'd like to say. But you would probably want to have a test to verify that you had got the controls that you thought you had. You had got an edit box where you thought it was. You had got a button that you could click and a results element, or whatever was necessary, an important aspect of your structure. But we're going to go straight in there. We're going to have a dummy search server. We're going to have our search UI, which is what we're actually testing, a class that implements the UI for this dialog box. We're going to put it's a non-owning pointer to the server because, hey, it's a dummy. It lives in the test rather than being passed in. We're going to create the display object. We're then going to simulate our user text entry on the search box button in the display, and we're going to search for red widgets. And then we're going to simulate a click on the search button. And then, of course, we're going to check that the results, the server did receive a request, and it was a request for a search of red widgets. Now, I've just used assert. Assert.h is a standard part of every C++ implementation out there. If you like, you can use a fancy framework. No, there are many out there. Use Boost Test, use Google Test, use Catch, whatever. But you don't need it. You don't need a framework to write tests. You can just use assert. Some people, when I say I use assert for my tests, think that I'm thinking contracts, and at the top of my function I assert which things are valid and not. I mean, in my test function, I stick an assert in and use just the basic assert function. So it breaks into the debugger when the test fails. It's nice. But what we do have is we have these functions, simulate user text entry and simulate user click, which are things we're going to have to write. And I'll show you some code for that in a minute. But the framework doesn't provide them for us. So this is one of the things that makes it difficult writing user interface tests, is because we have to write these functions, whereas in jQuery we didn't have to do that. Okay, so here's our class definition for our UI. It's an MFC class, derives from C dialog. Takes in a shared pointer to our search server, which is going to be an abstract interface. Just forwarded it, declared it at the top. We've got our create function, which is actually going to create the UI. And then we've got an MFC message map, and in our message map, we're going to have a map to say when the search button's clicked, call this function. So there's our message map at the bottom on the search button, and our button click function is quite straightforward. Take the string, get the text from the search box, and call search on our search server that we provided. Dead easy. Obviously, at this point, we're not testing that we're doing anything with the results, so we don't need to care how we get the results back. When it comes to getting the results back, we'll have to think about that. We might have to go back and edit that and change the function. But for now, that's all we're thinking about. So, and this code will make the test pass, assuming that our dummy search server correctly records the search details. Okay, as I said, the C++ frameworks don't make it easy to simulate our interactions. So we have to write our own. We've got, in that example, simulate user text entry and simulate user click. Test support functions, they're essential because they're not straightforward. So on Windows, you've got 3 ways that I can think of for automating the UI in your code. Okay, the first is that you could use the official Windows UI automation API to simulate your user interactions. There's a lot of scaffolding involved in doing that. I've had a look at that on several occasions and just thought, ooh, stand back. No, for writing a simple simulate user text entry function, that is a lot of scaffolding and framework. So you can use it if you're going to drive a whole sequence of UI interactions in one go, like you were writing a full acceptance test tool that drives your UI drives your application through the UI, then that's probably a great framework to use. But for fine-grained tests, it's a lot of scaffolding. Second thing you do is you could just send input API, which allows you to send key presses and mouse events to the system. The downside with that one is that you need to work very hard to make sure that they actually get routed to the right windows, because the send input just submits it to the operating system. Somebody pressed a key, and you need to make sure that the right window's got the focus, so that key goes to the window you're trying to test. As if if something pops up, there's a nice little notification pops up in the corner, say, oh, you've just unplugged your power cable. Suddenly you've got a message box in the middle of the screen, and that one gets the enter key. Oh dear, that's not what you wanted. So it can be hard work to actually make send input be focused enough to test what you're trying to test. The third option is to send messages to your controls to update their content. So you've got an edit box, so you send it a message saying update your contents, and then you look up the documentation for the edit box. What messages does my edit box send when if the user enters something? And so then you send those messages to the window that would receive them. I prefer that option. It's straightforward. You can write a function that fits on a page, on a slide that does this for your edit box, and it's quite clean, and it trusts that the edit box does what it's supposed to in production, and then tests how your code responds to that. Because that's what we're not testing the edit box. We're testing our code. So we're sending the message that the edit box sends, or the button sends when it's clicked. And how does our application respond to that? And yes, you will need to. No, these functions are complicated enough that you probably ought to write a little loop to test them and to verify that you do indeed get the same message as you did when you typed in a box. But that's more complicated, and you only never need to do it once per these functions. So here is our simulate user text entry function. It does indeed fit on one slide. We pass in the window, the control ID, and the text that we want to enter. We get the MFC object that represents that control, which might be a made-up one on the spot. MFC is quite nice like that. If there isn't already an object bound to it, it will just give you one. We assert that indeed what was one. So we didn't have an explicit test to verify that there was an edit box, but if you try and call simulate user text entry and there isn't an edit box, it will assert. Then we check that what we've got actually is an edit box. It's all very well saying, simulate user text entry, going to type onto a button, type onto a picture control. Doesn't do anything. We're going to type in an edit box, and only an edit box. Get class name is a little helper function that I wrote because it it's about 3 lines to actually do get the class name of a window, but it's not complicated. Okay, then we check that it's enabled, because if the edit box isn't enabled, you can't type in it. Okay, so now we know that we've got an edit box and it is enabled, so we can actually cast it to an edit control and say, now we can send it edit control messages. And so then we check that the length of that text is going to fit. And if it isn't, then we truncate it. If you're pasting from the clipboard and you paste in a 3,000 word essay into an edit box that's only got a 50 character length, it only pastes the first 50 characters. So that's really what we're simulating here. So then we set the text. We check that we have got a parent for our edit control that's actually going to receive the Windows message, and then we send it a Windows message that says our text changed. So this is the bit at the bottom. So those last few lines are where we're actually doing the work. We're setting the text on the edit control, and then we're notifying the application that our edit control changed. So those are the really interesting bits at the bottom that actually do the simulation. And we're going to need those variety of those for every single type of thing that we're wanting to simulate. Now, if you want to simulate a button click, then these lines at the bottom, it will be a different message. It won't be en change. It will be bn click. And obviously you won't be setting the window text on a button, but whatever. If you've got a drop-down list selection, then again you'll be programmatically send the message to the drop-down list, choose which of your text entry it is, and make that the selected one, and then send the notification. My selection's changed. If you right-clicked on something, then you send a message to say it's a right-click, and this time you're going to need to know where it's been right-clicked. Or you could simulate that actually someone's pressed the context key button, context menu button, which lots of applications ignore, because people forget about that one. If you've got a menu, then you could simulate navigating the menu, or you can just simulate the message that comes when the menu is selected. And obviously it depends. If you're writing custom menus, you're going to want to simulate the navigation. But for most menus, you just send the notification. Say, this was the menu that was selected. But you're going to have to write the send message call. And for all the other different combo boxes, whatever type of control you've got, if you're interacting here, you're going to have to write the support function. But you only need to write each support function once, and then you can reuse it for all your applications. Okay, quick guidelines. Firstly, this is TDD, so mock out everything that isn't the focus of what you're testing. We don't care about database access, we're writing a UI, mock it out. We don't care about files, we're writing a UI, mock it out. Even other UI components. If your UI is supposed to pop up a message box, then don't have it pop up a message box, because that then is a modal interaction with the user. Have it instead say, call a function that says, I want to pop up a message box, because you're going to have that all over the place. So you can test that itself in a focused thing, have a little function that pops up a message box with the required message and with the required buttons. Is it yes? Is it just an OK? Is it got an error? Is it a yes, no, cancel? No. Have a function that does that. But then all the rest of your UI code can call that function, and you can call a test version of that function in your tests and verify that you've got the right error message, that it's got the right flags, that it's got the right creating the message box with the right buttons. If it's supposed to pop up a new dialog of whatever sort, then no. If it's a file open dialog because you're trying to give it a file name to save, then just have an interface with a function that says, give me a file name. And then in your test, you can give a hard-coded file name. Whereas in the production code, you can then have it prompt the user. And of course, you will then want a test for that function that's going to prompt the user, but that's its own thing. Okay, next guideline is trust the framework. Rely on the controls you're using doing what they're supposed to. Query them for their data and settings, but don't test the pixels unless you are actually testing the graphical display of a control, and that is what you are testing. You are testing this control, does it display correctly? In which case, you jolly well want to test those pixels. But otherwise, you don't care what the pixels are. No, somebody's changed the theme on their browser, somebody's changed the version of their OS, somebody's using Chrome rather than Safari. The actual pixels are going to be different, but we don't care. What we care is that the behaviour is right. So query, there is a control, it has these properties, it has this text, it has this graph with this set of data with this scale on the axis. Test that. Don't test that it's drawn with a wiggly line that looks like this. You trust that your graph control does that. If your controls don't provide that facility, so that from the test you can't query that, wrap them. Create your own custom control that does provide that, that when you set a property, it stashes the value set as well as setting it on the underlying control that's going to do the display. And then you can test, was the value set correctly, because you can query your custom control, which is a simple wrapper around the actual UI component that you're using. Write the library of support functions, but write each function as you need it, and use the framework where you can. And then finally, of course, it's your standard TDD cycle, red-green refactor. Don't forget the refactor, because you will end up with lots of duplication, particularly in your tests. And take baby steps. Do the simplest thing that could possibly work. So test the simplest thing that's next, and then write the simplest thing that will make your test pass. And then, of course, hey, it's development. Have fun.